Hi, my name is Bodhi. I'm a data science student at SMU, and today I'm here to present a beer study that we did for Budweiser. So Budweiser gave us two data sets. One was a beer set, and the beer set told us how bitter the beer was, defined by its IBU, and its alcoholic concentration, defined as its ABV value, style of beer, in ounces. The brewery set just told us the name of the brewery and its location, defined as city and state. So after looking at the brewery set, we wanted to get an idea where breweries were concentrated at the state level. So we see Colorado has the highest number of breweries at 47, California 39, Michigan 32, Oregon 29, Texas 28. So we expect to see the majority of the beer within the study to come out of these states since they have the highest number of breweries at the state level. So an issue that we had during the study was that 42% of our beer data was missing for its bitterness and alcohol concentration values. IBU is defined as ounces times alpha acid times boiling time divided by 725. So it's a 4-variable equation, but through substitution, we can make it a 3-variable equation. So after doing that, we defined x as x, or alpha acid times boiling time. Then we looked at every beer that had an IBU value, and we calculated what its x value would be. Then we averaged that x value on the style level to come up with a style factor. So then any beer that was missing its bitterness value, we applied that style factor to it to come up with a derived IBU. We did the same approach for the alcoholic concentration, except the difference is that ABV is defined as original gravity minus final gravity times the constant 131.25, and we substitute for y instead of x, and we applied it on the style factor as well. So after solving for the missing data, we wanted to get a more sense of the data on the state level. So we graphed the median bitterness on the state level, and we see Delaware has the highest medium IBU of 67, West Virginia at 57.5, and then we have a three-way tie for third place between Minnesota, Massachusetts, and Vermont at 45. And then looking at the medium alcohol concentration on the state level, we see Kentucky has a highest medium ABV of 6.45%, DC at 6.25%, West Virginia at 6.2%, New Mexico at 6.1%, and Alabama at 6%. So after looking at the mediums, we wanted to look at the highest. So the highest IBU on the state level is Illinois with a value of 164.85, Oregon at 138, Virginia at 135, Massachusetts at 130, Ohio at 126. So if we look at the highest ABV on the state level, we see Colorado has the highest at 12.8%, Kentucky at 12.5%, Indiana at 12%, and New York at 10%. So this is all very conflicting data in terms of what consumer preferences are, right? So we wanted just to look at alcoholic concentration of all the beers. So regardless of the style of beer, we see that most beers have a alcoholic concentration between 4.9% and 5.9%. So generally, it seems that consumers are more concerned with the bitterness of the beer rather than the ABV of the beer. Building on this, we wanted to look at the relationship between the bitterness and the alcoholic concentration of the beer. So we see a strong linear relationship of 0.6. In other words, as bitterness increases, so do the alcoholic concentration. And this could just be a symptom of fermentation. The longer something fermentates, the higher alcoholic concentration you have of the beer, and the more bitter it is. And we see these outliers within the beer. Perhaps that's due to the ingredients of the beer. Maybe these beers are using different ingredients, and that is the explanation for it. So after looking at the relationship between alcoholic concentration and bitterness, we wanted to narrow it down to two profiles of beers. So we looked at the profile of IPA and ale. Generally, IPAs have a higher bitterness and alcoholic concentration, which we see as evidence of this graph and evidence of the steeper slope. The reason perhaps we see variation in the ale is due to different ingredients that the beers are using. You don't see that much variation in IPAs because IPAs generally use the same type of ingredients, which is why they're IPAs. But we wanted to statistically prove that the profiles of these two beers are different in order to have more comfort in classifying a beer as ale or IPA due to its ABV and IBU profile. So what I did is we took the mean IBU of ale and IPA beer, and we used a t-test, and the results of the t-test showed that we could reject the null hypothesis and accept the alternative hypothesis that the mean's true difference is not 0. So what this means is that statistically these beers are different, and we have further confirmation that we can classify these beers as two different things. So what I did is we used a K&N test, which is clustering, and we back tested it within the data set, and we were able to successfully identify if a beer was an ale or an IPA with a 90% accuracy rate. So the additional value of this study is that we think the area for entry would be the ale beer market. They appear to be more popular than IPAs, as evidence of how many more ales are within the study than IPAs. We think that states of entry would be states that have breweries between 12 to 26. The reason for this range is that we think there's enough of market share to grab and it's not overly saturated. And if you went under 12, perhaps you don't have the consumer base that would be interested in purchasing an ale beer. So that's how we arrived at this range. And thank you for your time today. Have a great day.